So why would you use trig substitution? Well, if you look at these two problems right here, the one on the left can be done pretty easily using u sub. The one on the right, you kind of can't do that. So let's take a quick look. So if you u sub this, you would say u equals 1 minus x squared. And your du would be equal to negative 2x, right? So you could pretty easily plug in a 2 over here, and then go negative 1/2 x to compensate, and you're all set to go on this problem. The only issue is the one on the right isn't so easy. It's the same exact u sub if you were going to u sub. U minus x du equals negative 2x. The only issue is you don't have an x out front, and you can't just put one out front, right? We know that. So you're kind of out of luck on that one. This is where you would use something like a trig substitution. So there's really three main steps to doing these things. First off, you're going to identify which trig sub to make. You're going to integrate all the trig stuff. And then the one that people forget really often, so you got to remember it, is undoing the trig substitutions we make in step 1. And we're going to do that with a type of triangle type method. So these are pretty specific types of problems. You start to recognize when you need to use it. You begin to see like square root and some stuff below it that looks familiar, and you automatically will start thinking trig sub. Definitely, like, the more you do of these, the better you'll get at recognizing it, and it won't be that difficult. Oh, and actually, just to clarify, this should be negative in there, not regular positive too. So if you were to look at a few problems like this, your first thought is, how the heck do I do this, right? Because you have a sine squared plus a cosine squared underneath square root. And you wouldn't really know how to integrate that, but then if you actually start thinking about the trig identity, right? So down here you have sine squared x plus cosine squared x equals 1. Well, you could just replace the sine squared x plus cosine squared x with 1, and you would end up with something like this. 1 square root of 1 dx, right? And that really just equals, right, which is just the integral of dx, basically. And then you could do the same thing as you come down into the next one, right? So 1 minus sine squared of x is really just cosine squared of x using the same thing, right? So if you subtracted sine squared of x from this side and the sine squared of x from this side, you'd get cosine squared of x equals 1 minus sine squared of x. So you can use that same identity and say, well, that's just cosine squared of x dx, and that just equals the integral of cos of x dx, and we know how to actually integrate that. And that's the same thing with all of these, right? You can do 1 minus cosine squared of x is just sine squared of x. 1 plus tan squared of x is just secant squared of x. 1 plus cotangent squared of x is just cosecant squared of x, and secant squared of x minus 1 is just tan squared of x. And you can get these other ones by just dividing this by either, like if you divide it up by, cosecant squared of x, cosecant squared of x, everything by cosecant squared of x, you would end up with, what is this? This would be tan squared of x plus 1 equals secant squared of x. Right, and you can do the same thing, and then you can start subtracting sides and whatnot, but you can do the same exact thing with dividing this by sine squared of x. Then you would come up with the cotangent and cosecant squared of x's. So right now we're going to look at step 1 of trig substitution, and that's really just identifying which trig substitution to make. This stuff gets much, much easier after you do a bunch of these. Initially, you're looking at the square root, and you want to see kind of which identity, or does this look like some identity we know, right? 1 minus x squared, well, that kind of looks like 1 minus sine squared or 1 minus cosine squared, and we know what that is. That equals either cosine squared or sine squared. So let's just go ahead and set x. We'll say x equals sine of theta, right? So we need to use a theta here, right? We can't use x again, so we'll say x equals sine of theta. So if we plug that in, well actually let's do the dx first, right? Dx equals cosine of theta d theta. So if we actually plug in the sine of theta for x, we get 1 minus sine squared of theta, and then that's still dx, right? So now the issue here is, one, we have a dx, and we can't have mixed terms in here, so we actually have to sub in the dx for whatever that equals. So 1 minus sine squared of theta, and then dx equals cosine theta d theta, right? Now this is where the whole identity comes in. 1 minus sine squared of theta, well that's just cosine squared of theta, right? Using the Pythagorean identity. So you can write this as cosine squared of theta times cos theta d theta. And then you can go ahead and say, well, cosine squared of theta is just cos of theta, right? Underneath the square root, you take the square root of it. So you have cosine of theta times cosine of theta d theta, and obviously at the end you end up with the integral of cosine squared of theta d theta. So that is, in its entirety, step 1, right? You're going to do that over and over and over in these problems. But that is step 1 altogether. So let's do an entire problem here, an entire trig sub problem. Technically you could do this problem with u substitution, but let's pretend the directions say to do it with just trig substitution. So initially, you're looking underneath your radical and you want to get this thing equal to something that looks like something that you can use an identity on, right? So in this case we're going to use x equals 3 tangent of theta, right? Your dx is 3 secant squared of theta d theta. Now the reason why we actually use a 3 in here, and you'll see why moving forward, is we actually have to, we don't have a constant of 1 out here, right? We have a 9. So how do we get rid of that 9? And I'll show you that moving forward once we plug in. But we're going to do that by doing a little bit of magic by putting this 3 in here. And basically when you replace that 3, you'll see we can actually wipe out that 9. So we'll start by plugging in, right? We plug in our, for x up top, we have 3 tan of theta, is what we set that equal to, right? Below that, we have x squared, so 3 squared is going to be 9. Tangent squared is tan squared of theta, plus 9 is what we had. And then we have to replace the dx with our new dx, which is just 3 secant squared theta d theta. Right, so that's where we are right now. Now our next step is going to be to actually factor this 9 out from underneath. So we're still going to have 3 tan theta up top, but below we can factor the 9 out. So now it's 9, and then it's tan squared of theta plus 1, right? And then we still have the 3 secant squared theta d theta. Now tan squared of theta plus 1 is just secant squared of theta, right, by the identity. So we can actually do two things. One, we can say, well, let's go ahead and just simplify that for now. Let's say 3 tan of theta, let's say it's 9, and then underneath here we're also going to say it's equivalent to secant squared of theta, right, by the identity. 3 secant squared of theta d theta is still out there. Right, now underneath here you can actually do two things. One, you're going to take the square root of 9, right, because you can do that easily. Square root of 9 is just 3, so now that becomes 3. And then you're going to take this, you're going to take the square root of secant squared theta as well. And that is just secant of theta. And then you have 3 tan of theta, still up there. And then you have 3 secant squared theta d theta, right? So here's where the magic starts to happen. You can start to cancel out the 3's, right? And then secant of theta, well, you have 2 secants of theta over here, so you can cancel that. That'll cancel the squared. And then you're just left with the integral of tan of theta, well, actually 3 tan theta secant theta d theta. So we'll rewrite that, and you'll see we're just left with. We can move the 3 out front, right? So tan theta secant of theta d theta. Actually, I should have wrote that the other way. Secant of theta, tan of theta. Just so that it looks a little bit more of like something you know. But either way, that is in itself, if you take the integral of secant of theta, tan of theta, that's just secant of theta, right? So that equals 3 secant theta, no d theta, plus c. So we'll rewrite what our answer was up until this point up at the top of the paper, just so we don't forget it. I don't have enough room. 3 secant theta plus c, right? And our original x was 3 tan of theta, right? So that was our original x, and then our partial solution up to this point that we just got. But now, they were originally looking for this in terms of x, not in terms of theta. So we actually have to get the proper terms back, right? We have to get this in terms of x. So how do we do that? Well, we do this thing, this is like the third step of trig sub. And you draw a triangle. Right? It seems weird, but you do the same thing every time. That's theta, right? So what you're gonna do is you're gonna say, well, what do we know? Well, up here we have this. Well, we know x equals 3 tan of theta, right? So here's our triangle and our angle theta. Well, tan of theta is just, if you divide both sides by 3, it's just x over 3 is equal to tan of theta, right? So tan of theta equals to x over 3. So tan, or TOA, if you use your SOHCAHTOA thing, is opposite over adjacent. So opposite is just x, adjacent is 3. So to come up with a hypotenuse, you would use Pythagorean, and so like let's say this is, I don't know, just question mark, right? Question mark squared equals 3 squared plus x squared, and then you would just take the square root of this, and you'd say that equals the square root of, well, that's 9 plus x squared. So this is just 9 plus x squared, and you can get rid of that. So that's what you're going to do every time, basically. You're going to have this triangle that you end up setting up, and then you use your information that you initially set up as your x to basically derive the sides of the triangle. And there's going to be some different things they're going to throw at you. They might use like an arctan or something like that, or an arcsin or something, and you might have to, cancel out some stuff. And but either way, it's going to come down to the same thing. You're going to set up your triangle and figure out what all the sides are of it most of the time. So then you would say, okay, well now 3, your answer is just 3. Secant of theta, well, secant is just 1 over cos, right? So 1 over cos, which is, let's see. So to finish this thing off, we just need to get our answer back in terms of x's. So we have secant equals 1 over cos, which is 1 over adjacent over hypotenuse, which is hypotenuse over adjacent. If you use your SOHCAHTOA, that's what you'd come up with. And, so we have, our initial answer was 3 secant theta plus c. Well, so we can start writing that as 3, and then secant of theta we can get just doing this, which is hypotenuse over adjacent. Well, hypotenuse is just, let me write this down below actually so it's a little bit more clear, but so the hypotenuse is just 9 plus x squared over, and then adjacent, which is 3, plus c. And as you can see, the 3's will cancel, right? So it's really just ends up being 9 plus x squared, all underneath the radical, the square root, plus c, and that's your final answer. That's how all these are going to be. They're going to go through those 3 steps. They're going to basically say, here's some problem. You have to actually figure out what trig sub to make. You make the trig sub, then you simplify everything, and then take the integral of that stuff, right? And then once you have the integral of it, you'll end up with something like this, which is 3, secant theta plus c, or something like that. Then you have to get everything. Remember, then that's a triangle step, right? That's the one that people forget all the time. Sometimes they'll leave it like this, but obviously you can't do that. You have to get everything back in terms of x. So you set up your triangle, do all that stuff, use your initial x term, right? And then you just work it out and figure out your final answer. And that's pretty much it for a trig sub.